Okay, so the first technique we'll learn for animation in a digital system is based on this idea of cell animation that we talked about. So I'm going to call this section Cell Animation for Digital Systems. And it's just like you might imagine. You create these scenes by having a background and you layer on top, and to save yourself some work, okay? So it's really common to compose a scene using these layers. So especially if you're on a limited system or an old system, you could imagine pre-rendering the background. And you might be thinking that these are dead techniques, but you know, I have kids, and every now and then you'll come across like a digital system, and they'll sell them cheap, like a video game system or something for kids, and it's handheld or it's really low tech. And you look at this and you go, oh, that's kind of cool. They're using, these old techniques. And in computer science, if you've been around long enough, you see the old get deprecated and come back again. It just keeps happening this way. Another place where I've seen these techniques is in embedded systems. You're making a display for a tractor or something. You don't have all this high-tech stuff we're talking about. You're back to old tech. Memory and speed and battery life matters. These techniques can serve you just fine. So here's the idea. We have our scene, and you could imagine drawing your background first, and you have this really nice background. There's a lake, there's mountains, I don't know, there's a river, snow in the mountains. You have this really nice background. Put a sun up there for good measure. And then what you do is you have your background. Then what you do is you draw on top. You draw these things called sprites on top. So what all that sprites are, it's kind of a computer sciencey word. Computer science might be the wrong word for it. Game culture kind of word. And all that it is it's a small raster graphic. Okay, but if someone says it's a sprite, it's not just a small raster graphic. It's a small raster graphic that's specifically designed for this kind of animation and this kind of scene composure. Okay, it's specifically designed to be composed into a scene by layers, typically. You might get technical. Some really old Spike graphics didn't have layers. They had tiles instead. But that's like an edge case. But basically, when people say sprite graphics, this is what they mean. You have these nice backgrounds that you do somehow, and you can put sprites on top. Here's Jim on vacation, and what you didn't see in the frame is maybe there's a troll over here. He's unhappy. He's about to eat me. And there's a bird in the sky making fun of me, that kind of thing. So you put these sprites on top of the scene, and you have a really nice scene. And you compose that with these pieces, just like in cell animation, where you overlay these transparent bits. So the way that it works when you want to make things move or change, it's commonly called frame-based animation. So frame-based animation, so what you've done so far in the class has all really been vector graphics, right? You keep things in numbers, you keep them in vector graphics, triangles, you rasterize at the final step, but before you do that, you can do what you want with them. You can stretch them, you can resize them, you can rotate them, you can project them, and then you rasterize at the end. We don't get to do that with sprites. They're just rasters. So to get animation, the most common technique is this frame-based animation, where we basically pre-draw sequences of images. Okay? And we pre-draw these sequences of images, and they're designed to be played in order. I shouldn't say played, I should say drawn. Designed to be drawn sequentially in order, which is what sequentially means, I know, to give the illusion of motion. Okay? Just like classic film. Where in classic film we have this series of pictures that you show Same thing, we pre-render them and we show them. So you can imagine that you, oh yeah, first maybe I'll say this is typically done not as a whole scene. Like you don't pre-render the whole scene and show it as an animation, although that works just fine, but it's more typically done on a per sprite basis. Okay, because there's a lot of optimizations you can do. If you're just changing one character, instead of redrawing the whole scene, you can redraw the background behind them, draw them on top, draw the background, draw them on top, and it's significantly less work. So it's typically done on a per sprite basis, not the whole scene, okay? Again, this is like cell animation. So it's the same idea. It's probably not a coincidence. It's probably not a coincidence that they work the same way. You can imagine if you have a series of, you have a person walking, right? And then the next scene, their legs down, and then the next scene, to open a little bit, just like your flip book, right? So you pre-render all of these scenes, and then you have a frame-based animation. You draw one after the other on screen. Okay, so really, really simple. These sprites are usually given a transparent background. Okay, so it's transparent, so you can put it on top of the scene and not everything's a square, right? Which is really nice. Again, like cell animation. Okay, to support drawing on the background. So this is quite nice. You have this frame animation here, and what you do is you indicate somehow that this is transparent, so that this is all transparent. So when it draws Jim walking on top of the background, all the transparent areas don't show through, so you get these transparencies. There's a couple of ways to do this. You can imagine having an alpha channel, but this requires more bits per pixel. Another standard technique, you have these magic colors, and by magic I mean reserved color. So if it's a palette color, let's say you have 256 colors in your palette, you can imagine, oh no, 255, forget that color, that's my transparency. Or if you're using RGB, you might say, well, you know, perfect gray 127, 127, 127. You make up a number that's unlikely, you fix that as your transparent color, okay? So that's something that you'll see people do. Okay, and this is a standard way to do things. This frame-based animation, this is the standard for sprite graphics, okay? It's what you'll see. You go back to play an original Nintendo, a Super Nintendo, any of those old computer games, you'll see those sprite graphics, and they're done this kind of way. Even some of the early 3D games like Wolfenstein 3D or Doom, they actually use a technique called billboarding, where you have a 3D scene, but you have a sprite as the object, and that's why it doesn't quite work. If you look in Wolfenstein or Doom, when you move the thing, it stays facing you. It doesn't quite get perspective right. It's just a frame-based sprite on a 3D scene, so that's kind of cool. So this is a really nice technique, but there are problems with it. First of all, it's labor intensive. And the reason why it's labor intensive is because each frame has to be pre-rendered and pre-drawn by an artist. Has to be pre-rendered, okay? So each frame has to be pre-rendered, and that's a lot of work. Whereas in a 3D system that we've been doing, you put in some code and you can animate and squish things and move things. You don't have to do every frame. You can trust a computer to do it. It's memory intensive. Relatively so. Okay? Each frame has to be stored. Again, I should probably make that neater. Each frame has to be stored, whereas in the other techniques we've been learning, You just store a few points. You store some geometry as points, and you can render and do everything. You only have to store the geometry. You can render everything live. You don't have to store it. It uses less memory. This technique is pretty memory intensive, especially on the limited devices that we're talking about. However, it is extremely flexible. You can render whatever you want into each frame, and there's artistic license. If you have a bouncing ball and you're doing it in 3D and your artist goes to squish the ball when it bounces, you go, oh my god, how do I do that? But for sprite animation, they just draw it that way, and you can squish the ball when it bounces. It's really easy, so it's really flexible. In 3D, you got to solve that. Okay, it's also extremely fast. So all that you need is only memory copy. Right? There's no rasterization phase going on. And there's no transform pipeline. Transform. There's no transform pipeline. So it's really fast, which is why it was popular in the old days. This rasterization that we're going through in a transform pipeline is actually quite slow, so it doesn't really work well on a simple or old system. So let's look at demo number 2. Where is it? Did I kill it? There it is. So we have this demo here. Oh, I know what I should do. Let's just pause the video for a second. Okay, so what we've done is we've actually downloaded these wonderful pictures, these sprites. 1, 2, 3, 4, 5, 6, 7, 8, and they're pre-rendered scenes for frame-based animation. And this reminds me, I forgot something in my notes. Let's go back and let's add it. Where's the alpha channel? Yeah, I want to add in a note in here. There's transparency. Let's not do it that way. Let's try that again. There we go. Alpha channel. So it's small detail, but it's important to know, not every format supports transparency. Every file format. And if you've done much web stuff, you've learned this already. JPEG doesn't support transparency because of how it works using Fourier analysis. If you've done signal processing, it uses Fourier analysis in a block, and so it's actually quite tricky to put transparency in. I've heard about extensions where they use a mask on top of the image for transparency, but it's not standardized. No. .png or TIFF, those kinds of things, yes. So these days, if you want to use a graphic with transparency, use PNG. It stands for Portable Network Graphics. But that's the one you want to use. So let's go back to here. So we have these really cool frames, right? But what you have to do is, you can see already this is memory intensive compared to what your other programs did, right? Or your assignments. But this is what the program looks like. I have this file called, this data type called pimage. It's just a processing image. Whatever program you're using, framework you're using, you have to learn how to load images in. These days that should be pretty straightforward. We load each image. I'm going to load all however many I have of them, 8 of them, into sprites, and so I have this array of images, and then I've set the frame rate to 15, and then down here you can see that some fancy background, and this is important. I'll show why after. We're drawing this background with a color, and then what we do is we draw an image, each image, and this is a silly little X and Y calculation to make it at the right spot, but we're drawing it as an X and a Y. And then we move X to the right by 20 pixels, not 1, it's jumping ahead 20 pixels. Remember this persistence of vision and your brain filling in the gaps. It's jumping ahead 20 pixels. And then we increase the frame by 1, so the next time it'll draw the next frame. So it's going to draw frame 1, frame 2, frame 3, frame 4, and then it mods sprite length, so it'll loop that forever. So let's run this and see how it works. So 15 frames a second. Here's my cool background. How cool is that, right? So you can see, even though I only have 8 frames, it looks pretty smooth, right? Like your brain is pretty okay with it filling in those blanks. It's not actually moving that smoothly, but because of persistence of vision and how your brain fills in motion with something reasonable, we get this really nice effect. Also notice it has transparency. We have this blue background we've drawn, and it's drawn right on top of that. And again, it's actually moving 20 pixels at a time, but it looks like it's moving pretty smoothly. If I change this to 100 pixels at a time, it'll start to really break down. See, it starts to get choppy. Okay, he's running, but it's kind of blurry and choppy. It's not as smooth. And if I go down to 1 pixel a second, it's going to look really smooth, but of course he's moving painfully slow, if he ever shows up at all. So you can play with these parameters, but it's so freeing, right? That our eyes are so forgiving that we can make him move 20 pixels at a time, jump 20 pixels, and your brain goes, yeah, sure, why not? There he is running on ice or something. 1 pixel at a time. So a lot smoother, and again, you fill in those blanks. You could imagine you can make it smoother if you had more frames, but you don't really need to. And in early video games, they learned that. So this is our example of frame-based, did I cut out? Yeah, frame-based animation. Yeah, look at that. It looks really cool. You can change the speed that it moves at and how many frames, and your brain just fills in the blanks. It's really neat, really easy to use, and a really cool technique. All right, so let's stop there and we'll come back and learn about other techniques for digital animation.